So today I want to talk about measurement and why do we measure? What's the point of measuring anything? Uh, and the answer to that question is simply to describe matter numerically. We want to know how much matter is there or how much space that matter is taking up. We want to convey or communicate that information to somebody else. We're going to concentrate mainly on mass, volume, and density in this lecture. Uh, the metric system, to refresh your memory, is based on units of 10, and we start with the base unit, in this case liters, meters. Later we're going to talk about moles. You can talk about any base unit of which science has specific base units for each individual measurement that you're going to make. Uh, then you put a prefix in front of it. That prefix tells you where the decimal is. It tells you what power of 10 that measurement is. You're going to see kilo, centi, and milli most often. We're going to deal with micro and nano when we get really small and talk about sizes of atoms, things like that, or we'll talk about tera and giga. You should be familiar with those from the computer industry right now. When I was growing up, we were talking about kilobytes of memory. Then it went to megabytes and gigabytes. Now you can easily buy a terabyte hard drive. The next one is going to be 1 times 10 to the 15th. So this is this. These are really big. These are really small. When you see that negative, it means it's less than 1. When you see that it's a positive number, it means it's greater than 1. When we talk about the amount of matter present, we're just talking about mass. All right, the SI unit is the official unit. It's the official unit of mass set by scientists. That's going to be the kilogram. That's 1,000 grams. And here's some more conversions to kind of show you how these SI or how the prefixes work. Here we have 1,000 milligrams as 1 gram. Or we have 1 times 10 to the 6, which is 1,000,000 micrograms, is 1 gram. Here we have 1 times 10 to the 9th, which is 1,000,000,000 nanograms, is 1 gram. And so that's how those conversions kind of work. And we're going to deal with those quite a bit this year. I want to touch on the difference between mass and weight. In society, they're kind of used interchangeably, but they do mean two separate things. Your mass, as I just said, is a measure of how much substance is there, and your weight is the force of gravity acting on that substance. So when you get to physics next year, you're going to talk a lot more about weight and the forces that are acting on this mass. The important thing to remember, and why we use mass in science as opposed to weight, is mass is constant. It doesn't change based on where you are, whereas weight depends on the effect of gravity. So as an extreme, if you're on the moon, you have less gravity, therefore you're going to have less weight. You've always heard that you weigh less on the moon. Well, your mass is the same. You still have the same body. You still have the same amount of material there. You just don't have the same force acting on you. So we use mass. Volume is the amount of space matter takes up, which can be determined in various ways. It's the arrangement of those atoms, or the arrangement of the molecules in space. So we have length times width times height, which you're familiar with. You've been doing this since the 1st grade, 2nd grade. Well, probably since you learned multiplication, maybe the 4th grade. If you have an easily measurable sides, if you have a cube or a rectangle, you can figure out the shape. You've done this with cylinders and cubes and all kinds of different shapes in geometry and other classes. We have graduated cylinders, which we'll be using quite a bit in this class. Think of these as measuring cups. These are used for measuring the volume of liquids. When you buy a graduated cylinder, it is accurate to so many decimal places, and we'll talk more about that this year as well in the next week. Finding volume by displacement is another technique you'll do in the next few days. This is using a graduated cylinder and putting an object into the graduated cylinder with liquid already in it and measuring how much further up the liquid goes. We'll do this. The SI unit for volume is the cubic meter. It's not a liter, it's not cups, it's not gallons. It is the cubic meter, which means meter times meter times meter. Meters cubed. Conveniently, 1 cubic meter does equal 1 milliliter. 1,000 milliliters equals a liter. 1,000,000 microliters equals a liter. 1,000,000,000 nanoliters equals a liter. Those are just some conversions to help you get a grasp on these prefixes again. We will deal in milliliters most of the time. Occasionally we'll talk about cubic centimeters as well. The comparison of mass to volume is called density. Density is an intrinsic value or an intensive measurement to a substance. It's constant. We know that water at 4 degrees Celsius is always 1.0 grams per cubic centimeter. That means 1 gram of water is going to occupy 1 cubic centimeter space. So if you have a cube that is 1 centimeter on each side, that should have a mass of 1 gram if it is pure water at 4 degrees. As we'll talk throughout the year, it does depend on temperature, and there are charts, and these have been experimentally determined, and you can just look it up if you needed to know what is the density of water at 25 degrees Celsius or at 0 degrees Celsius. Obviously, you've learned previously that when you have ice, ice is less dense than water, so once you cross that freezing point, once you get below 0 degrees, this is going to go way down. When you get above 100 degrees, it's going to go, your density is going to go down as well because you've turned it into a gas. Your formula here is density equals mass divided by volume. All right, so this is a very simple formula to use, and I'm going to work a couple examples in just a second. Density is something that is used quite a bit for determining an unknown. If you have two substances, you can determine the density and figure out what a substance is based on that clue. So here's an example. What is the density of, let me go to my pointer, go to my pen. Let me change this to black so you can see it. What is the density of a substance if it has, if 2.5 milliliters has a mass of 2.75 grams? So here we have 2.5 milliliters and we have 2.75 grams. So we have our formula. I keep hitting my button. Density equals mass divided by volume, or D equals M over V. Alright, when you see grams, that tells you you have a mass. Your ml, your milliliters, gives you a volume. So those are the two numbers you're going to put in here. So you have density equals 2.75 grams divided by 2.5 milliliters. So then you're going to get at your calculator and you're going to do that calculation. So in your calculator, put 2.75 divided by 2.5, and that gives you an answer of 1.1. And your unit is going to be a combination. It's going to be derived, is what we call it. It's going to be grams divided by milliliters. So you have grams divided by milliliters. It's always important to include your unit. And that's your answer right there. Another example, we're solving for something else. We have aluminum has a density of 2.700 grams per cubic centimeter. What is the mass of 2.500 cubic centimeters of aluminum? Technical difficulties. Your density is going to be equal to mass divided by volume. Alright, so the first thing you got to figure out is what are we given here? We have centimeters cubed. That's going to be a volume. You're also given grams divided by centimeters cubed. What you need to be working on in this class is recognizing, what does a unit tell you? This tells you have mass and volume. So this is your density. When you see a mass divided by a volume, that's going to be a density. So you have 2.700 equals x, which is your mass, divided by 2.500. So now to solve for x, you're going to cross multiply. So you'll have 2.700 times 2.500 equals x. Now get out your calculator and say 2.700 times 2.500, and that gives you an answer of 6.75 equals x. Now you need to put a unit on that. Here we had grams per centimeter, so this is grams per centimeter, this is centimeters cubed. So your answer here is going to be a mass. Alright, your mass always has a unit of grams, so your answer is 6.75 grams. Alright. This concludes the brief explanation of measurement. You've got plenty of practice that you can be working on. If you have any questions, go through this video again or ask your teacher.